All right, hello everybody. Welcome to this week's Q&A video. Sorry, this is a little late. I got sick last week, but excuses. All right, so we had 3 questions this week. First one, someone asked for clarification on interaction terms, so we'll go over those. Second question is going to be on interpreting models with logarithms. And then the final one is finding data for the final paper. Okay. So let's start off with interaction terms. So if you remember from the lecture, we use interaction terms when the effect of one variable changes with the value of another variable. So our example we had was we interacted, we said the price of a house was equal to a function of the number of bedrooms, the square footage of the house, and an interaction term of the two. So we would just multiply the two together. And just include that term that we created. Sorry about that. Include this term that we created as a control variable and just run this regression. Okay, so for an example, not from the lecture, let's say we're wondering whether or not the return to education is different for married and unmarried women. Okay, so that's the effect of one variable, education, depends on the value of another variable, in this case, whether or not you're married. Okay, so the way we could figure this out is we could do wage, estimate a model where wage is a function of your education. I think it's called grade in our data set, but that's just years of education. Whether or not you're married, and then an interaction term between the two. Okay, so let's jump into Stata. Okay, this is the National Longitudinal Study of Women 1988 data set, so this is included with Stata. And so we have all these variables here. So first thing we need to do is we need to create our interaction term. So let's say generate interaction equals married. Married is just a binary variable that's 1 if the woman is married, times grade. Okay, I guess there were some with missing data. That's okay. Stata will drop those automatically. Let's generate log wage equals ln of wage. We learned in the lecture last week that we should usually take logarithms of wages and prices, dollar values, because there's a lot of variance and they don't go below 0. Okay, so now let's run a regression. We want to regress. Our dependent variable is going to be our log wage. Our independent variable, we want grade, we want married, and we want our interaction. And you know, why not, since we're learning all the things from last week, let's make sure to use heteroscedasticity, robust standard errors. All right, and let's go. All right, and here are our results. Okay, so how would we interpret this? Well, this is where you asked in your question about something about partial derivatives. Well, if we want to find the, typically when we want the effect of grade on wage, we just look at the coefficient, right? But this interaction term makes things complicated. Okay, so what we have to do is take a partial derivative, or you can just remember this formula, that the effect of grade is going to equal beta 1 plus beta 3 times whatever the married value is. So we could have a different effect for grade depending on whether or not you're married. The reason calculus comes into this is actually the partial derivative of wage with respect to grade. And you can do the same thing for married. This is the partial derivative of, this is the partial derivative of our wage expression with respect to married. But you don't have to worry about this calculus. You can just know that when you have an interaction term, the effect of a variable, you include both the coefficient on that variable plus the coefficient on the interaction term times the value that you're interacting. Okay, so for example, we could find two pieces of information from our regression that we just ran. We could find the return to 1 year of education for married women. Okay, so that would just be saying that our married variable, sorry, this is messy, so I'm getting used to this drawing tablet. Our married variable is equal to 1. So what we would do is we would take the coefficient on grade, 0.9, plus our coefficient on our interaction term, negative 0.07. It's 0.007, right? Times married, which is just 1. And so the return to 1 year of education for married women is 0.092, or about 9.2% per year. We could also go the other way. We could find, we often talk about the marriage wage premium. Married people make more money. So what's the marriage premium for high school graduates? So that would be grade equals 12. So what we'd have to do is we take the coefficient on married, which is 0.07, plus our interaction term, negative 0.007, times 12. And so when we bust out our calculator, 0.007 times 12 minus 0.07, we get negative 0.01. So married high school grads make about 1% less than unmarried high school grads. But let's find it for college graduates. So in this case, grade would equal 16. All right, and that's going to be equal to, again, just 0.07 plus negative 0.007 times 16. So we'll do 0.07 minus 0.007 times 0.007 times 16 is 0.112 minus 0.07. Yeah, so here we get negative 0.042, or 4.2%. So we found that for high school graduates, or let's just say, for individuals with low education, married women make 1% less on average. But for high education, married women make 4% less. There's a greater penalty to wages for getting married for higher levels of education. Maybe this is because you're foregoing more labor market opportunities when you get married, and maybe married women are more likely to work part-time. So the opportunity cost of marriage is higher when you have a higher education. So ladies, take note. Okay, so I hope that clears up interaction terms. If you have any other questions, just let me know. I'm happy to go over it again in a different context. I wouldn't, if you are thinking about using an interaction term in your final paper, but you're not sure how to specify it, just let me know and we can talk about it. All right. Next one was interpreting log models. I think I said something in the lecture slide that was confusing. All right. So there are basically we can create a topography of 4 types of models that use logs. All right. So first is the one we already know or already knew. We know about all of these because we've all watched the videos and memorized them. It's the level specification where it's just y equals all right. Next one is called the log level. We actually just ran one of these. This was our wage regression that we just ran. All right, then we have the level log, where we leave y alone, and we take the log of x. And then finally, the log, where we take the log of y. What am I doing? Take the log of y and the log of x. Okay, so how the interpretation of the coefficient is different in all 3 of these. All right, so for this one, it's simple. It's a 1 unit. Make this. Maybe I just need to press less hard. A 1 unit increase in x leads to a beta 1 unit increase in y. All right, and this one is a 1 unit increase in x leads to a beta 1 times 100% increase in y. Okay, and I think this one here, the level log specification, was where the confusion was, because what I said was a 100% increase in x has a, creates a beta 1 unit change in y. I think I got a result that where beta 1 was like 0.7. And so you would interpret that as saying a 100% increase in x has a 0.7 unit change in y. And what I said is a 10% increase in x. So this is, so a 100% change in x leads to a 0.7, so beta 1 equals 0.7. 0.7 change in y. And what I said is a 10% increase in x led to a 0.07 change in y. So I just divided it by 10. So this is something you can do. So if your variable doubling doesn't make sense, you can just change the way you phrase it, but we're not changing anything. So that's where the 10% came from that was I think, confusing a student. I hope that clears things up. And then the last one is a 100% increase in x leads to a beta 1 times 100% increase in y. Okay, so that's, I hope that clears up what was going on with log models. Okay, but what I want to talk about now is data for your final paper. Okay, so I think people asked about this. And so I'm going to show you, I think, 3 data sources that I think might be helpful, especially if you don't have a topic yet. I think that often what can happen is that students have this great topic in mind and then there's no data for it. So it can often help to start by finding data and then discover your topic within that data so you don't have to point up with that. Okay, so the first data set I'm going to show you is called the General Social Survey. And if you have no idea what your topic is yet, you're just flailing around looking for a place to start, this is where I would start. This is one of the best data sets available for social scientists. Okay, and you can find it by just Googling General Social Survey here and clicking on GSS Data Explorer. And you can, let me see if I can sign in. You can make an account and it's free, and there's actually a reason why you might want to make an account, and I'll show you why. Okay, so you get here, you go to search GSS variables, and basically what the GSS is since 1972, this group of social scientists has gathered a huge sample of people and asked them, thousands of questions about, anything you could possibly think of. Okay, so the thing to remember, though, is that it is cross-sectional. But it's pooled. Okay, so every year is a different group of people. Okay, so you can see, one question they might, first question they ask is, how many hours did you work last week? And you can see that every time they run the survey, they ask a different group of people, how many hours did you work last week? Okay, so that's what's important to remember when dealing with this. But again, you can filter by topics. This is really good for public opinion data, but you can do questions that we've already talked about in class, like the return to education. I don't know. Freedom. Let's see what variables on freedom there are. How much freedom does R have? So this is, R means respondent. Okay, so this is just asking people how free they feel. All right, and if there's a variable that interests you, and this is why I recommend you go to the GSS first. Where is it? You click on this button, and it'll add it to the cart, and we'll see that again later. Okay, let's get a measurement of income. We already have total family income. That's probably good enough. Sex. Let's just start with that. Okay, so here's the really cool thing about this website is if you go to Actions, you can extract data, you can download it to go in Stata, but if you are using Stata on a different computer or you're just feeling lazy, you can actually run regressions on this website. We'll call it Freedom. In the movie Braveheart. And you kind of have to tinker around with it. So we only want the year 2000 because that's the only time we asked this question about freedom. All right, let's put in total family income. And let's put in let's just do a binary, sorry, not binary, bivariate regression for now. But we want to do two things in this case selection. We only want to include the people who rated it on a scale of 1 to 5. We'll drop these people because it could mess with our analysis. And then for income, again, this is coded, but as long as it's going up, each one of these is about $1,000. But we just don't want to include the refused or don't answered because those people, it would read as them having a higher income, but they wouldn't actually have a higher income. Okay. Yeah, okay, let's run this. So we click create analysis. Again, this is really simple. All right, you have to wait. Let's see if richer people feel more free than poorer people. Okay, here's our result. And we find, look, our income variable is negative 0.04, and it's statistically significant at the, beyond the 1% level. So rich people actually feel much less free than poor people. What could that mean? Maybe we should add controls. Maybe there's omitted variable bias. Look, you already have a project. So obviously this wouldn't be enough for your paper, but we're already getting started thinking about stuff, and you can do it all from your browser. So that's the first one, is the General Social Survey, and it's cross-sectional. It's, micro topics. It's at like the individual level. Yeah, okay, so that's the General Social Survey. That's where I recommend you start if you aren't sure what your topic is. Okay, the next one is what's called the National Longitudinal Study of Youth. Again, you can Google this, or you can just search NLSY. Click on the first one. There have actually been two, the 97 one and the 79 one. I don't know why they chose those 2 years except to make it confusing. But you need to get to the, here it is, NLS Investigator. And again, it's in the name, but what separates this from the General Social Survey is that this is longitudinal data. Longitudinal. Meaning that they follow the same people from year to year. So, in 1979, they asked a bunch of questions to a group of kids, and then 2 years later, they went to those same kids and asked them the same questions, and they did this, they're still doing it into these kids' adulthoods, and then they did the same thing in 1997. So there are two what are called cohorts of people that the study has been following for decades and decades now. Okay, so if you need longitudinal data on individuals, this is a great place to start. Okay, exploring data works similarly to the way it did in the General Social Survey. You search, employment. This is, again, marriage. You can look at risky behaviors. You can look at health. You can look at attitudes. So this is kind of like that. If they're training, if they're working with their hands, how much time do they use the internet? Again, this is, you can explore this, but here you can't run a regression in the browser. That's just the GSS that you can do that with. But you can download it in Stata format. Okay, so if you need longitudinal data, nlsinfo.org/investigator is the place to go. All right, so that's 3, 2. I guess I gave you 2 sources of this is micro data. again at the individual level. All right, third is the World Bank. I actually had you do this for a problem set, but stands as a good reminder. So actually, I can just tell you it's data.worldbank.org. And so here we have, I guess you have to click one more time. World Development Indicators. And so here we have macro data. And I guess it's longitudinal in that it's at the country level. So they are following countries over time. And so this is where you want to go if you're interested in development economics, if you're interested in some macro stuff. But you can see there are a billion different variables here. And so if you want to run a regression where countries are your unit of analysis, this is where you'd want to go. All right, one last one. And to analyze this data, you'd need techniques that we haven't actually covered yet. We'll cover them in a couple weeks. But it is the Federal Reserve Economic Database, or FRED. Let me just search FRED. FRED data. And this is where you get a lot of macro and time series. Okay, so, if we want, this is US only, I should also say that. Not always, but I think the vast majority of this is US only. All right, because this is a project of the Federal Reserve. Okay, so let's say we want the Dow Jones Industrial Average. All right, the cool thing about FRED is that if you have Stata, you go into Data, Import, you see all of these options. Look at this right here. You can click on this. Did I click on it? Yeah, and you want to look up the FRED key. So let's see, where is that? I forget where it is because I don't do a lot of macro. Can I just search? I remember being able to search. Oh, this is to, okay, I have to do this differently. Once you have to kind of activate Stata to work with FRED, so you have to make an account, but it's really simple. Okay, that's what it does. Once you put in, so now I look really stupid on video. Once you put in the key, then you can actually search FRED from Stata and grab these macro data sets and just import them right into Stata. They'll already be cleaned and everything. Well, not cleaned, but labeled. You can also just download it as CSV and import it if you feel like that. Okay, so can you tell I don't do macro? All right, so those are 4 data sets that you can start with. The General Social Survey, which is your go-to source for cross-sectional microdata. You can also run regressions right in the browser window. If you need longitudinal microdata, you want to go for the National Longitudinal Study of Youth. If you want macro data at the country level, you want to compare countries and maybe compare countries over time. You go to the World Bank, World Development Indicators. And if you're looking for time series for the US, check out the Federal Reserve Economic Database. If you're still, if you have a topic that you really have set your heart on, but you still can't find data for it, let me know, and maybe I'll let you know where you could track down something that could help. But for now, those were the questions we had. Again, I'm sorry this was delayed. I will talk to you on Monday about regression discontinuity designs. See you then.